Hello बच्चों, let's read the question. Let alpha is equals to minus 1 plus I times root 3 divided by 2 if a is equals to 1 plus alpha times summation k equals 0 to 100 of alpha raised to 2k and b is equals to summation k equals 0 to 100 of alpha raised to 3k, then a and b are the roots of the quadratic equation. Option 1, x squared minus 102 times x plus 101 equals 0. Option 2, x squared plus 101 times x plus 100 equals to 0. Option 3, x squared minus 101 times x plus 100 equals to 0. Or option 4, x squared plus 102 times x plus 101 equals to 0. Solution शुरू करने से पहले let's note down the key concepts for this problem. So the first key concept is if omega belongs to the set of complex numbers is cube root of unity, then omega cubed is equal to 1. The second key concept is for a geometric series summation k goes from 0 to n of a times r raised to n, where r is the common ratio. This sum is equal to a times 1 minus r raised to n plus 1 divided by 1 minus r for r not equal to 1. The third key concept is the quadratic equation to which alpha and beta are roots is x squared minus sum of roots, that is alpha plus beta times x, plus product of roots, that is alpha times beta, equals to 0. Now with these concepts, let's now start our solution. In the given question, we have been given alpha is equal to minus 1 plus I times root 3 divided by 2. A is equal to 1 plus alpha times sum k equals 0 to 100 of alpha raised to 2k, while b is equal to summation k equals 0 to 100 of alpha raised to 3 times k. Now since alpha is minus 1 plus I times root 3 divided by 2, this can be written as alpha equals to e raised to I 2 pi by 3, which is cube root of unity. Therefore, we have alpha cubed equal to 1. Now, let's first get the value for a. Since a is equal to 1 plus alpha times summation k equals 0 to 100 of alpha raised to 2k. Now here you can see we have a geometric series with common ratio alpha squared and the first term as 1. So, using the key concept, we can now write the sum as 1 minus alpha squared raised to 101 divided by 1 minus alpha squared. So that is 1 plus alpha times 1 minus alpha raised to 202 divided by 1 minus alpha squared. Now we first need to get the value for alpha raised to 202. Now since alpha cubed is equal to 1 and alpha raised to 3 times h is equal to 1 for every h belongs to set of integers. Now further we also have alpha raised to 202 equals alpha raised to 201 times alpha. Since for h equals 67, 3 times h is equals to 201, and so therefore alpha raised to 202 will be equal to 1 times alpha, that is alpha. Let's substitute. So we have 1 plus alpha times 1 minus alpha divided by 1 minus alpha squared. In the numerator we have 1 plus alpha times 1 minus alpha, that is a plus b times a minus b. Use the formula, so we get 1 minus alpha squared divided by 1 minus alpha squared, which is equal to 1. So finally we have value for a as 1. Now let's get the value for b. So b is equal to sum k goes from 0 to 100 of alpha cubed raised to k. So here we have, since alpha cube is equal to 1, so therefore we have summation k equals 0 to 100 of alpha cubed raised to k, that is equal to summation k equals 0 to 100 of 1. Now the number of terms we have is k equals 0 to 100, that is 101 terms. So the sum will be 101. So therefore we get the value for b as 101. Now let's use the value of a and b to get the required quadratic equation. So the quadratic equation with roots a equals 1 and b equals 101 is x squared minus sum of roots, that is 1 plus 101, that is 102 times x, plus product of a and b, that is 101, equals to 0. So the required quadratic equation is x squared minus 102 times x plus 101 equals 0. So among the options, option 1, x squared minus 102 times x plus 101 equals to 0 is the correct answer. I hope you understood it well. Best of luck and thank you.